Let's discuss about few theorems based on symmetric and skew symmetric matrices. Okay, so there are two theorems. Let's discuss the first one now. See, the first theorem, it's basically more like a property / theorem, you can say. Okay, now what the theorem states is, suppose if A is a square matrix, okay, A is any square matrix, then A plus A transpose is always a symmetric matrix, always, and A minus A transpose is always a skew symmetric matrix. This is always a skew symmetric matrix. Now this is the first theorem. Okay, now let's prove this one. Let's prove this one. Now to prove that a matrix is a symmetric matrix, the matrix and the transpose of it, it should be the same, correct? Only then we call it as a symmetric matrix. Now in the sense, let's say that, okay, let's take that B is equal to A plus A transpose. Now if I prove that B and B transpose are one and the same, that's exactly what we mean by it's a symmetric matrix. Let's prove this one. Okay, now first what we'll do, we'll take B transpose. So B transpose is equal to A plus A transpose whole transpose. Now we'll use the properties of the transpose. This becomes A transpose plus A transpose whole transpose. This is nothing but A transpose plus A. A transpose plus A is nothing but B, isn't it? So what did we prove? We proved that B transpose is equal to B. Correct? So this is basically the first theorem. That is, A plus A transpose is a symmetric matrix and A minus A transpose is a skew symmetric matrix for all A being a square matrix. Clear? This is the first theorem. Now let's move on to the second theorem. The second theorem, what does it say is, suppose you have A being some square matrix. Okay, so A is a square matrix. Now this square matrix, A being a square matrix, we can represent this as sum of symmetric and skew symmetric matrix. In the sense, we can write the same square matrix as A is equal to half of A plus A transpose plus half of A minus A transpose. Now we have already proved that A plus A transpose is symmetric and A minus A transpose is skew symmetric. So what we have is, when you add symmetric and skew symmetric matrix, we are going to get the same matrix back. Okay, now this is a very important theorem. Fair enough? Because you have a lot of problems based on this one. Now just to prove like how we are going to do this theorem, let me give you an example. We'll start with the 2 cross 2 matrix, a very simple one. Okay, so let me show just one example. Say A is equal to 1, 4, 5, 3. Okay, 1, 4, 5, 3. Now first thing what we'll do, we'll calculate A transpose. So when you take A transpose will become 1, 5, 4, 3. Row becomes column, column becomes row. Isn't it? Now the next step is what? We'll prove the symmetric matrix part. That is, we'll do A plus A transpose. This becomes 1, 4, 5, 3 plus transpose 1, 5, 4, 3. When you take the sum, you will get 2, 10, 2, you get 9, then 6. It's a symmetric matrix, correct? Now we'll do the skew symmetric matrix part. Okay, so for the skew symmetric matrix, what we'll do, A minus A transpose 1, 4, 5, 3 minus 1, 5, 4, 3. This becomes 0, minus 1, 1, 0. See, this is a skew symmetric matrix, correct? Now what we are going to do? We are going to prove that the square matrix A is the sum of the symmetric and skew symmetric matrix divided by 2, half of it, correct? So what we'll do? We'll do half of A plus A transpose plus half of A minus A transpose. Okay, so this is going to become half of 2996 plus half of 0 minus 1, 1, 0. Okay, let's do the math and let's figure it out. Now, if you add these two, so what you are going to get? See, 2 divided by 2 is 1, correct? So, we'll get 1, 9 by 2, 9 by 2 and 3. This is the first part. Plus, the next part is going to be 0, minus 1 by 2, 1 by 2 and 0. Correct? Guys, when you add these two, so what you will get? You will get 1, 9 by 2 minus 1 by 2 is 8 by 2 and 8 by 2 is nothing but 4. 9 by 2 plus 1 by 2, which is basically 10 by 2, 5, 3. Yeah, we got A, isn't it? This is nothing but A. So we just proved that sum of symmetric and skew symmetric matrices is going to give us the square matrix back. But the questions will be in such a way that they'll ask you that express this square matrix in terms of the sum of symmetric and skew symmetric matrices. So in that way, we have to write that the symmetric matrix is given by this one. This is the symmetric matrix, correct? And the skew symmetric matrix is given by this one. This is the skew symmetric matrix. Okay, so the square matrix A can be represented as symmetric and skew symmetric matrix. Fair enough? So these are the two theorems what we have based on symmetric and skew symmetric matrices. Alright, in the next video, we'll solve few problems based on transpose and symmetric and skew symmetric matrices.